question B here, which is asking you to find the limit as x tends to negative infinity of 3x, sorry, 3 times e to the 6x minus 7 times e to the 5x plus e to the x, all divided by 4 e to the 5x plus 3, right? So now obviously here you have exponential functions, and it's also important to note that more or less the same, you could say the same rule that we were using for polynomials would apply here, because if you think about it, as x tends to a higher and higher value, right? For example, 3, if you look at the positive infinity, right? So 3 times e to the 6x will be closer to infinity than all the other terms, because all the other terms have an exponent that is lower, right, of a lower degree, right? So you could reasonably assume that you can only consider the term with the highest exponent in x, right? So that's in the case where x is tending to positive infinity. So in the case where x is tending to negative infinity, right, you sort of
Hi, Jonathan.
yes, go ahead.
Yes. So what if you had the e to the power of x, so the one with the highest degree in the denominator? Would you still apply the same thing? Divide by that.
Yes, it's also, so let's say you, for example, you're saying in the case where you have let's assume that
Maybe
it
that
was
3
positive infinity, yeah,
x was in
right?
the
And then you
denominator.
had e to the 7, something like that.
No, maybe if you had that 3 e to the power of 6x, if you had that in the denominator, yes, like that actually. Yeah.
Or
Would you?
something like this. So the denominator has a higher degree than the numerator.
Yes.
The same would apply. You
Okay.
would only consider, right, so that's in the case, you would only consider the highest degree in the numerator divided by the highest degree in the denominator, right? Same, but as soon as you start doing it, you can sort of see intuitively that if x is tending to infinity and you have a higher degree in the numerator, or rather, let's say you have a higher degree in the denominator, then you'll see that you'll basically be dividing a smaller number in the numerator by a bigger number in the denominator. So it will tend to 0,
0.
right?
Yes.
So in most of those cases, you will see that it tends to 0. But now, if you look at the negative case, now this is an interesting case because once again, you'll still consider, because it's all going to infinity. So all of these terms are basically um, closer and closer to 0, right? So you will also consider the highest degree here, because the highest degree still gives you a good representation of where the limit is going, right? So both in the numerator and the denominator. And by that I mean you can basically just ignore all the terms with the lower degrees, right? And that's only when x is tending to an infinite value. So, and when you do that, oh, sorry, I forgot to change this back. We have 5 there and a 5 there, right? So when you do that, you have that, obviously you have e times, sorry, e to the 6x, which can simplify with e to the 5x in the denominator, right? So please mute yourselves, guys. I can hear paper in the background. So yes, so then you can simplify this further by subtracting 5 from the exponent in the, getting rid of the e to the 5x there, and subtracting 5 from the 6 there. So you have just x left, right? basically simplified. And then when you do that, right, you will now have 3 times e to the x over 4, and x is tending to negative infinity, right? So if you plug in the value of x there, you can clearly see that this is going to be e to the negative infinity, right? So you'll have 3 times e to the negative infinity, right? And oh, let me just e to the negative
So
infinity
Jonathan,
divided by 4. Yes.
in this case, you didn't divide each term separately by e to the power of 6x, ne? You didn't do that. Why?
What do you, oh, you could do that as well. It ends up
Because doing that,
it
I
should
just
end up.
this is my final answer.
Sorry?
For my final answer, I had 3.
You had 3. Okay, so you divided by the highest degree.
Each term, yeah.
No, okay, so that means you divided by 3 to the
No,
6x, both in the numerator and denominator.
yeah. E to the 6x in the numerator and denominator.
Let's try that. I don't see why it should cause a problem. Let's try that. So when you do that, you basically divide it by e to the 6x here, right? And e to the 6x in the denominator as well, right? And obviously that will mean that you have I think that's actually the better way to think about this. Yeah, that makes more sense. I think the better way to think about it is to use this way. Yes, you divide by the highest degree, both in the numerator and in the denominator. And then when you do that, it would simplify to b, right? In the numerator, you would get so you get 3 minus 7, right? Divided by e to the x plus 1 over e to the 5x. And then in the denominator, you would get 4 divided by e to the x, right? Plus 3 divided by e to the 6x, right? Now, the one issue that I have when you do that is, as you can see, right, so yeah, I think that's where I was a bit, wait, let me just copy this and then go back. Just bear with me. Okay, so if you use that method, right, you end up getting what? In the denominator. So if you look in the denominator, you'll have 4 times e to the 5x, right, divided by e to the 6x, right, which will give you 4 over e to the x, right, plus 3 over e to the 6x. So what happens when you substitute the value of of x there, right? So actually, I think it ends up giving you the same answer, so never mind. So you would get, right, in the numerator, you'd get 3, right, minus, rather 3 minus infinity, right? Because you have 7 over e to the negative infinity. Sorry, not... Yes, 7 over e to the negative infinity, which is just, let me just write it down so it makes more sense. So minus 7 times e to the negative x, let me just change it as that, plus e to the negative 5x, right? All divided by, in the denominator, 4 times e to the x, sorry, negative x, plus 3 times e to the negative 6x, right? That's what you would have in the denominator. But now what happens when you have that? When you have that, what happens is that when you substitute the value of x, right, you will have infinity of infinity, right? I hope you can see that.
Yes, I do
Okay,
see.
so you'll have infinity of infinity, which will require you to end up using L'Hopital's rule, which is not what we want. Okay. Yeah, so you would get infinity of infinity, which means that you might have to use L'Hopital's rule. And that means that you're just going around in circles. But remember that in an exam setting, you're not really trying to take too long for a question like this. You want to be fast, which is why I think you can use the simplification that we used before. Because from that, you can already tell that as soon as you substitute the value of x at the end here, you get 3 over 4 times e to the minus infinity is just 0, right? So it will basically be 0. And
Okay, so basically with that method, the other terms kind of fall away with the lower degrees.
exactly, yes.
Okay.
And one way you can do this as well, I think online, as when you're just studying for this, if you want to go back looking at this problem, I think you can also sketch this function and look at what happens when x tends to infinity. There's those, because that's what the limit is, right? So there's those programs that you can use online to sketch functions like this. So try to sketch this function and look at what happens as x tends to infinity. If it gets closer and closer to 0, then you know we did the right thing. So that's another thing you can, another method you can use to figure out if what we did is correct, right?
Okay.
So just think about it that way, yeah.
Yes, and also
So now,
you said specifically for the negative one, right? Only if it's tending to negative infinity.
well,
Or also,
the same applies for positive infinity as well, because you would still get rid of the highest degree.
lower.
Well, to still just go back to your notes and try to read more about that, the case of negative infinity and positive infinity. But I believe it should be the same, right? Yeah. Just confirm back on that. So what I was asking was if you guys had seen Taylor series expansions.
No, we haven't.
No. Okay, so that means you at this point you might not be able to solve sub-question C, because with sub-question C, as you can see, you have the limit as x tends to 0 of sine inverse of 6x divided by sine inverse of 10x.
Excuse me,
Right?
Jonathan. Sorry, I'm
Yeah.
so sorry. Mhlongo did do that question, and he solved it by substituting variables to replace sine, and sine. Yeah.
Oh, okay, that's fine then. That's one way.
Is that
Well,
what Taylor series is?
he did this one.
See, yeah, he had something very similar. If it wasn't that.
He substituted what? What do you mean? He did
So
what?
he let sine inverse 6x be y1 and the other one be y2, and then he took the thing. He said sine y1 is equal to sine.
Oh, okay. Oh yeah, that's a nice way as well. So okay, so saying you're basically changing the variables. So you let, for example, yeah, this be equal to y1. Oh, sorry, just so this be equal to y1, and then the other one be equal to. Oh, that's a nice way to solve it as well. So, but another way you could think of is using Taylor series expansion. But you guys, I think you guys will see that next semester, because then you can express the sine inverse function in terms of a polynomial, and then you'll be able to just use the rules for polynomials to solve these limits. But that's another way to do this. So if y1 is equal to sine inverse, then it just basically means that sine of y1 is equal to 6x, right? And then that just means that okay, so yeah, right. So then the same would apply for y2. So you would have sine of y2 therefore is equal to 10x, right? And then as soon as you have that, now you know that as x tends to 0, right? Because that's the limit that we have. If x is equal to 0 in the first expression here, you have that sine of y1, right? Sine of y1, oh, sine of y1 is equal to 0, right? And that would just mean that y1 is tending to it's tending to 0 as well, right? So y1 is tending to 0, right? And then for the second one, you'd have that y2 as x tends to 0, you'd have that y2 is also equal to is also tending to 0, right? So basically y1 and y2 are equal, right? So then you would use okay, yeah. So then you would transform the limit in such a form that you have now you have a limit in terms of y instead of a limit in terms of x, and then you solve for the limits. Yeah, I guess that's one way to do it. So there's, as you can see, there's multiple ways to do this. So the one way you could do it is using L'Hopital's rule, but you're not allowed to do that for this specific question. The other way would be Taylor series expansion, but you guys have not seen that yet, so that's in next semester. And then the third way is to just use the method that he used, Dr. Mshlongo, because I think that method might be more appropriate for a case like this. So just try to see what he did and try to apply it to this problem. I wasn't sure that if you guys did Taylor series, because it's also very nice when you apply it to a problem like this, because it basically makes use of your limits, which sorry, not limits, but derivatives, which you guys have seen already. So I guess they took it out of the syllabus this year, or they pushed it to the second semester. Right. So basically, just go back to to his way of solving it. I'm not sure if it was in the revision sessions or not, but just go back to his way of solving it and have a look for the specific problem. Because as you know, these are all exam questions, so you would want to practice with as many problems as you can. So now if you move on to sub-question D here, you have the limit as x tends to negative infinity, right, of 2x minus 3 over the square root of 16 x squared plus x plus 7 plus 32. Now for this one, the same rule that we used before, right? The first two problems apply. So we'll take the highest degree in the numerator, so the highest order, 2x, right? And divided by the highest, the term with the highest degree in the denominator, which was just the square root of 16x squared. But another, you have to pay attention to the fact that x is tending to negative infinity, right? So when x is tending to negative infinity, here for the square roots, you'll just have 4, right? Because 4 is a constant, multiplied by the absolute value, right, of x. And since x is tending to a negative value, you'll have that the absolute value here will just be equal to negative x, right? And the x in the numerator and the x in the denominator can cancel. So you will get the limit as x tends to negative infinity of 2 over negative 4. Which will just give you negative 1 over 2, right? So that should be your final answer there. Any questions? Okay, so for the next one here, we have, once again, the limit as x tends to 2 of 1 over x minus 2 minus 2 over x squared minus 2x, right? So here, we're not allowed to use L'Hopital's rule because, but as you can see, if you substitute the value of x there, you'll just get 1 over something closer to 0, which will just give you infinity minus infinity, right? So what you would do here is you try to simplify the expression. So let's try to put it to the same denominator. So as you can see, x minus 2 is common between the two, right? So you can factorize that second fraction like that. And when you put it to the same denominator now, the common factor will be, right? Let's just go. So the common factor will be, so in the denominator we'll have x minus 2 multiplied by x, right? So then, in the numerator, you will have, for the first fraction, you'll have x, right? So it's x minus 2 times x divided by x minus 2 will just give you x minus 2, right? That's already there. Multiplied, oh, minus just 2, right? So then, when you simplify further, you can see that x minus 2 is common again, right? So x minus 2 is common between the numerator and denominator. So when you simplify, you have 1 left in the numerator divided by x in the denominator. So as the limits tends to 2, you'll have rather as x tends to 2, you'll have the limit tending to 1 over 2. Right. Any questions there? Right, so then next, if you look at the limits as x tends to 0 of x minus sine over 4, minus sine 4x over 2x. Here, you have to use a little bit of manipulation as well. So the first thing that you can think of is first separate the two terms into two separate fractions, right? So you'll have x over 2x, right, minus sine of 4x over 2x, right? So that's the limit that you will have. And basically, what this amounts to will be two limits, right? So you can simplify the first fraction because you have x is common on the numerator and denominator. So you basically have the limit of 1 over 2, which is just 1 over 2. And then on the right-hand side, right, you will be left with basically the limit as x tends to 0 of sine sine 4x over 2x, right? So when you evaluate that limit, you guys remember that you remember from your identities, that when you have the limit of as x tends to 0 of sine a over ax, this will just give you a, right? Now a can be anything. A can be a positive or a negative value, right? But in most cases, it's a positive value. So when you do something like that, and this results, I think I've mentioned it in the previous examples that we solved when we used this result, it was found using L'Hopital's rule. Okay, so as an aside, right? Let's try to prove it. So if you have x tends to infinity of sine ax over ax, a is a constant, you substitute, you'll have 0 over 0. So you can use L'Hopital's rule there, right? I'm just using L'Hopital's rule to show you where they got this to be true for every sine function, right? So using L'Hopital's rule, you would have to derive the numerator and the denominator separately, right? So if you do that, you will get in the numerator, oh, I think I made a mistake. It should be 1. So you'll get in the yeah, it should be 1 there. Sorry. You will get in the numerator a, right, multiplied by cos ax, right? And in the denominator, you'll have just a, right? And when you simplify that, you'll have that a will cancel in the numerator and denominator. So you will be left with the limit, the limit as x tends to 0 of cos ax, right? And that will just be 1, right? It will just be 1. So that's where the results of this limit comes from, right? So now you can see that for this to apply, you need to have the same factor next to x in the sine function as the one next to x in the denominator, right? But in our case, we have sine of 4x over 2x. So what you will do is you can multiply it by 2 and divide by 2, right? So you multiply it by 2 in the denominator, you get 4 there, but you also multiply it by 2 in the numerator, right? So it can cancel. It's a constant, so it doesn't really affect your calculations of the actual limit, right? But it just allows you to use the expression that you guys know from before. So you would have now 1 over 2 minus 2, right? Multiplied by because 2 is a constant, can come out, right? Multiplied by the limits as x tends to 0 of sine 4x over 4, which will then give you 1. So then you'll have 1 over 2 minus 2, right? Which will just be negative 3 over 2, I think, if I'm not mistaken. Yeah. So then, yeah. Right. So that is it for that question. And then if you look at the next question, you have the limit as x tends to 0 of x to the 4 times cos of 2 over x. Now, if I were to ask you, what method do you think you can use here to solve this problem?
It's a squeezing theorem.
Yes. So we'll use the squeezing theorem. And remember, the squeezing theorem tells you that if you can find the limits of functions that are related to a specific other function, then you can just equate that that limit to the one that you found. So when you do that, you know that for example, cos is equal, rather the cosine of a function is always between -1 and 1, right? So that means that if you were to try to get the cosine of 2 over x in the middle there to be something close to what we have there, you can multiply it by x to the 4 on all sides, right? So, and since x is raised to the 4, right, which is an even number, when you multiply it, it doesn't actually affect the sign of the inequality, right? Because it's not a negative number. So then you can easily just multiply it like this without having to change the sign of the inequality. And when you do that, and you introduce the limit, then you have that the limit as x tends to 0 of x to the 4 times cos of 2 over x will just be equal to the limit, right? Will just be equal to the limit as x tends to 0 of x to the 4, which will also be equal to the limit as x tends to to 0 of negative x to the 4, right? And when you find that limit, you'll find that it's just equal to 0. So therefore, you can conclude that the limit of as x tends to 0 of x to the 4 times cos of 2 over x is also equal to 0. Once again, for these functions where you use the squeezing theorem to find the limit, you can also try to sketch the function. There's multiple tools that you can use online to sketch functions, and try to see what it looks like. And then confirm that as x tends to 0, the function goes to 0. Then you know that your limit calculations are correct, right? So running out of time. So what I'll do is you guys will have to do then question 3 on your own. That's where you now using L'Hopital's rule, right? So for this question, just apply L'Hopital's rule to each of the limits and see what you get. Yeah, and this should be able to, you should be able to solve it.
Jonathan, I have a
Yeah.
question.
Yes.
Please can you help me solve something? It's not going to take long.